Welcome. Today we will explain how to easily provision an EKS cluster with MetaDefender Core installed on it. First, we will start explaining the recommended architecture for having MetaDefender Core installed on an EKS cluster. There are three main resources that are important to understand. First, the load balancer. It is going to be the access point for the user or client to make the request to the application. Second, the EKS cluster will be created, where we will install all of the main components required to have MetaDefender Core running within an EKS cluster. As you can see here, we have the service component that will automatically provision the load balancer for us in our Azure account. The third component is the MetaDefender Core application running as a pod that will be connected to a Postgres database. You have two options for the database. One option is creating a pod for having Postgres SQL database running within the cluster, or another option could be using the Azure Postgres service. For production environments, it's recommended to use the Azure Postgres service. Let's explain how to easily provision all these resources within the provision script called MetaDefender K8S, created by OPSWAT. These details are documented on the MetaDefender Core documentation page, where we list all the prerequisites like Terraform, Helm, Azure CLI, and kubectl. For setting up the credentials, it's important to set those as local environment variables before running the script. These local environment variables can be exported from a service account in Azure. For activating MetaDefender Core, we need to indicate the license key as a local environment variable as well. The parameters that can be used by this script are indicated in this table. The main parameters that we require are action. For this case, we'll choose provision, location, and here we'll select Azure, and then the correct MetaDefender product flag. In this case, we'll be installing MetaDefender Core. You can also run the script in Amazon or GCP, and those are covered in other videos. Some additional parameters that in this video we're going to use are namespace or cluster name. So now let's move to a terminal where I have the command ready to run. Here you can see the name MetaCore demo and the namespace MetaCore. Once we run the script, it's going to ask us if we want to run the latest version of MetaDefender Core, as we have not indicated a different image version. We'll select yes. The next question is, do you have your own access point, or do you want to create an ingress to access? We're going to indicate in this case our own access point, which will generate only a load balancer to access the service. For that load balancer, we can have attached a private or a public IP. We indicate public for this demo. Now the next question is, do you have your own or want to create a Postgres database? When using the script, it is possible to indicate that you have your own database, and then you just indicate to the script the host name, as well as the username and password of the database. However, in this case, we're going to create a new database running externally. We indicate the external database because we want the Azure Postgres service to be created for us. Then we provide a username and password. Here we see a summary of the selections and select Continue. You can see it is initializing Terraform, and the next command is Terraform Apply. That will list for us all the resources that are going to be created. We type yes here, and it will start to create other resources for us. This can take up to 8 minutes, so I'm going to pause the video now, and we'll come back once the provisioning is finished. Okay, we're back after around 8 minutes and can see that the provisioning is complete. You can see how the script has downloaded the context that is installed in our local environment, and then we're able to start the installation of MetaDefender Core within the cluster. For this, we're going to use Helm, and the script is checking to see if the MetaDefender Core license information is set up within the local environment variable. Now it will ask for the username and password for the MetaDefender Core UI. After confirming, it will start to install MetaDefender Core in the AKS cluster. We can see how MetaDefender Core is created in the namespace MetaCore as indicated prior. Let's run some kubectl commands to get the pods in the MetaCore namespace and some information about it. We can see that we have one pod that is initializing. So let's use the describe command on the pod to see how we are installing the image. In this case, we can see how it's starting to download the MetaDefender Core image and starting the init containers. After a couple minutes, the pod will be running and accessible from the UI. We can see that the pod is waiting for the readiness probe to check that the engines are installed within the container. Let's give it a try again in a couple minutes. You can see that the age of the pod is almost 2 minutes, and then the pod is running. Now let's check the service to see what public IP has been assigned to the load balancer by Azure. We now have a public IP to easily access the UI. We can see here that we have an external IP as public. Let's copy the IP and put it in the browser together with the port 8008. We can now get this started because it's already activated, and then sign in using the same credentials that we indicated within the scripts. And this is how you can easily provision an AKS cluster with MetaDefender Core installed on it. Thank you, and see you in the next video.